Alright, to do the angle relationships foldable, you're going to actually need this. I try to give this out to everyone. You're going to need maybe your clicky pen or multicolored pen. If not, it's no big deal, but I do like to color code. Calculator for some simple calculations. If you didn't get this, or if you lost it, what you could do is take, you would need 3 pieces of blank paper. If you kind of leave about an inch, inch and a half at the bottom, and stack them like that, so you'd have 1, 2, 3, and then fold. And again, don't go all the way down. You're going to go something like this, so that you have 1, 2, 3, 4, 5, 6 flaps. I like to staple up here, but you might not have a stapler. And then you could kind of just copy angle relationships, and then down here like that. 1, 2, 3, 4, 5, 6. Okay, so you could do that if you don't have this particular one. All right, let's go to adjacent angles. I'm going to flip this one up. So the definition of adjacent angle are 2 or more angles, but so 2 or more angles that share a common vertex and interior ray. And they're going to look something like this, where it's 2 angles or more put together side by side. So, number 1, name the angle adjacent to angle 3. So here's angle 3. The one next to it would be angle 1. Number 2, name the angle adjacent to angle ABD. So that would be angle DBC, or CBD if you want to go the other way. Now for both of these, in number 1, this point right here was the common vertex. This right here was the common ray. Over here, B was the common vertex, and BD was the common ray. Excuse me. Name the 2 angles adjacent to angle YZW. So YZW is this one. So we need 2 angles adjacent to it. So next to this one, we're going to call angle YZV. And then this one is next to it. And let's call it WZX. Z would be the common vertex, and depending on which angle you're talking about, it could be either this ray or this ray that they're sharing. Name the angle adjacent to angle AFB. AFB. So we're talking about this one here. So the one that's next to it is this one. That's angle CFB, and again, you could go the other way, BFC if you wanted to. All right, let's move on to complementary angles. So I'm going to open up that flap. All right, the definition, they add to 90 degrees. Okay, so complementary, you're going to see 90 degrees or right angles in them. So an illustration would be, let's make this 90, and it's 2 angles that when you put them together would make a 90-degree angle, so something like that. They might be separate, but when put together they would make a 90-degree angle. So if the measure of angle H and the measure of angle J are complementary, find the measure of angle J. So they give us this as 28. We want to find this, so one way to do this, 90 minus 28. If you need to, you'd use your calculator. I'm going to do this just, it's 62 degrees. All right, name a pair of complementary angles. Now, the only 2 that we know that would be complementary are the 2 that make this. The other 2 might be, but we know for sure that's 90 degrees. So we need the 2 that make that. So it's this one here and this one here. So let's name them. This would be angle BFC. again, you could go the opposite direction, CFB. And then this one would be CFD. Okay, and again, you could name those different ways, but those are the two that would definitely be complementary. All right, find the measure of two complementary angles, A and B, if the measure of angle A is 7x plus 4, and the measure of angle B is 4x plus 9. So we're going to throw in some algebra here. So what this is saying is that this angle plus this angle has to equal 90 degrees. So even though it's algebra, we can say 7x plus 4 plus the other angle, 4x plus 9, has to equal 90 degrees. That's what complementary angles do. A lot of ways you could solve this. I'm going to combine like terms. I get 11x plus 13 equals 90. If we start solving this, if you like the line, you can do the line. That would give us 11x is equal to 77. So that x equals 7. Now that doesn't answer the question. Alright, so I made a mistake. Don't mind that. So what I was saying is that we can take this x equals 7, put it in up here wherever we see an x. So 7 times 7 plus 4, that's 49 plus 4, that's 53 degrees. That must mean the other one we could substitute in 4 times 7 plus 9, or we could just do 90 minus 53 to get the other angle. So 30, I almost made another mistake, 37 degrees. Okay, over here find the value of x. So it's showing us that they make a 90 degree angle here. So that must mean that this 8x plus 5 plus this other one here, 3x plus 8, must equal 90 degrees. All right, so again, lots of ways to do this. I'm going to combine like terms. We get 11x plus 13 equals 90. It's going to be the same as this one. That's just by chance. All right, and it does ask what's the value of x? That's the value of x, so we've answered the question. Okay, moving on to supplementary angles. Supplementary angles add to 180 degrees. And they're going to look, there's a straight line somewhere. It doesn't have to be horizontal. Okay, but when put together, supplementary angles create a straight line someplace. All right, so angle F and the measure of angle G are supplementary. Find the measure of angle F. So they tell us that angle G is 132, so 180 minus 132. Again, you could use your calculator if you wanted to. So 48 degrees. Over here, name two pairs of supplementary angles. So there's actually 4 pairs you could name, but you only have to name 2. So I'm going to name this one and this one. So that's angle GED and angle DEF. All right. The other two, or there's actually, again, 3 more pairs. I'm going to do this one here and this one here. So that would be angle GEH and angle FEH. Okay, they make straight lines. There's actually 2 more. 2 more pairs, so 4 more angles that we could list. But anyway, find the measure of 2 supplementary angles, angle A and angle B, if the measure of angle A, 3x minus 7, and angle B is 2x plus 2. Okay, so even though these are algebra, we can still add them together. 3x minus 7. And because we're told that they're supplementary, they should equal 180 degrees after adding them together. So we'd get, after combining like terms, 5x minus 5 equals 180. Add 5. 5x is equal to 185. Divide by 5, and we get x is equal to 37, right? Yes. right, so that means that to find the measures of these angles, we would take 37 and plug it in for x. So 2 times 37 plus 2, that's 74 plus 2, that's 76, which means the other angle would be 180 minus 76, which is 104 degrees. Okay, so make sure you read the question. Are you finding the value of x or finding the measure of angles? Okay, over here, find the two angle measures. So we actually want the angle measure, not just what x is equal to. So we've got this one, and we've got this one. All right, so we've got 1/2, and then parentheses 6x minus 20, plus 1/4, 36x minus 8, I'm going to have to squeeze it in here, equals 180. Hopefully you can see that. That's equals 180. All right, now I'm going to distribute. All right, so half of 6x is 3x, half of minus 20 is minus 10. 1/4 or a quarter of 36x is 9x, a quarter of 8 is 2, equals 180. Now I'm going to combine like terms. I get 12x minus 12 equals 180. Add 12. We get 12x is equal to 192. Divide by 12. I think this is 16. Let me just make sure. 192 divided by 12. 16. All right. Now that doesn't answer the question. Find the two angle measures. So let's go back to the green one. I'm going to put 16 in place of x. So 1/4 of 36 times 16 minus 8. Definitely a calculator. So I'm going to do 0.25 for 1/4. 36 times 16 minus 8. And it gives us 142. So the other one, we could again use the algebra and substitute in, or I find it just easier to go 180 minus 142 and get 38 degrees. Okay, so again, read the question carefully. Are you finding the value of x, or are you finding the angle measure? All right, we're moving on to vertical angles. I'm going to flip this up. All right, the definition of vertical angles are the congruent angles formed when lines intersect. Now, you draw two intersecting lines. So the vertical angles, I call it a bow tie. It kind of looks like a bow tie. They're there, but they're also this way. So the vertical is kind of a weird name because they don't have to be vertical up and down. That's direction, I guess. Not exactly sure why they call them vertical. I'd have to look that up. When did they start calling them vertical? In any case, name the two pairs of vertical angles. So two pairs means we got to list 4. So that means angle 1 is congruent to angle 2. And then that would also mean that angle 3 is congruent to angle 4. Those are the two pairs of vertical angles. Name the angle vertical with angle VZY. So VZY is this one. So if we go directly across from it, that angle is its vertical angle. So to name it, let's do XZW. All right, down here, they intersect at P. Find the value of x. So let's notice that these are vertical angles, which means that they are equal to each other. So in this one, we're actually going to take 7 plus 13x and set it equal to negative 20 plus 16x. Now to solve this algebra, a couple ways you could do it, but I like to have variables only on one side. So to do that, I'm going to subtract off the 13x. I get 7 equals negative 20 plus 3x. So now I'm going to add 20. 27 equals 3x. I'll put it here. Divide by 3, you get x is equal to 9. Now, is that what they wanted, or did they want the angle measure? So find the value of x. So x equals 9. That's it. Done. Intersect at B, find the value of x. So this one and this one are equal. So 2x plus 20 equals 3x plus 15. So I'm going to subtract the 2x to get x is just on one side. 20 equals 1x, so x plus 15. I'm going to subtract 15, and I get x is equal to 5. And that answers the question, what is the value of x? Find the value of x and each angle if SOP, so SOP here, is 5x, and ROQ here is 4x plus 10. All right, so what we're going to do is set those equal to each other. 5x is equal to 4x plus 10. All right, so we're going to subtract 4x, change color. So we get 1x is equal to 10. That answers part of it. Find the value of x. Find each angle. So SOP, they said, was 5x, so it's 5 times 10. So angle SOP equals 50 degrees, which must mean that angle ROQ also equals 50 degrees. And would that work out? 4 times 10 is 40 plus 10 is 50. So yeah. And then finally, find the missing angle measures. So this one, let's just fill them in. So if this is 41 here, then that must mean angle 3 is 41 degrees. If, let me change here, if this is 72, go across, then angle 1 must be 72 degrees. Now, if we take a look any three of these angles, so let's say 1, 4, and 3, they are on a straight line, so that must mean that these three, or any of the, actually you could take any three that you want, have to equal 180 degrees. You could also go all the way around and do 360, but let's do 72 plus 41, it's 113, and then if we do 113 taken away from 180, we get that this is 67 degrees, which is the same as that. Okay, now you could double check again. You could go all the way around. They should add up to 360. Or just along the straight line, 180. All right, last one, linear pair. I'm going to have to do that. All right, so the definition are angles that lie on the same straight line, or same straight angle. Straight angle looks like a straight line. We could also put in here they add to 180 degrees. So we've already had a picture that looks like this, but that's a linear pair. Okay, so that's the same picture we had for supplementary. So find the measure of angle 2. So 180 minus 132 is 48 degrees. Name all the linear pairs. Well, there's going to actually be 4 of them. Angle 7 and angle 5. Angle 5 and angle 6. Angle 6 and angle 8. That's a 6. And then angle 7 and angle 8. All of those are linear pairs. So if we were to put them together, they'd equal 180 degrees. They intersect at M. Find LMO and OMN. LMO, this one. OMN, this one. They're a linear pair. A lot of people confuse this with vertical. They're not vertical. They're not across from each other. They're next to each other. So what we're going to do is 7x plus 20 not equals 10 plus 5x, but plus 10 plus 5x. And that has to equal 180 degrees. All right, so I'm going to combine. We get 12x plus 30 equals 180. Subtract 30. 12x equals 150. 50 divided by 12. 12.5. All right, now it says find the measure of LMO. Well, LMO was 7x plus 20, so 7 times 12.5 plus 20. All right, 7 times 12.5 plus 20. 107.5. The other one, we could just do 180 minus 107.5. 80 minus 107.5. 72.5. All right, over here, they're linear pair. That's another way to say they're supplementary. So 1/3 27x minus 6 plus 1/2 6x minus 20 equals 180. I'm going to distribute. All right, 1/3 of 27x is 9x. 1/3 of 6 is 2. Half of 6 is 3x. Half of 20 is minus 10 equals 180. All right, I'm going to combine. We get 12x minus 12 equals 180. Add 12. Divide by 12. Isn't that 16 again? Let me just double check. Yep. Now it just says find the value of x, so that's it. That's all we have to do, find the value of x. Down here, find the value of y and each angle in if the measure of SOP, so SOP is this one, and it says 7y minus 12. SOR, that's this one, right? 5y plus 12. So those two would add up to 180 degrees. So 7y minus 12 plus 5y plus 12 equals 180. All right, we get 12y is equal to, now minus 12 plus 12 makes 0, so it's gone. 180. Divide by 12, and I believe this is going to be 15. Now it says the value of y and each angle, so we'd have to do 7 times 15 minus 12 for SOP. That's 105 minus 12, which is 93. The other one, we could just do 180 minus 93, or you could do 5 times 15 plus 12. 93, so we should get 87 degrees. All right, last one. Value of x and each angle. So dBA, this one, dBC, dBC. All right, so we're going to add these together. They're a linear pair. Equals 180. All right, 4x plus 11x is 15x. 6 minus 6 is 0. Equals 180. Divide by 15, and we get x is 12. All right, so if x is 12, then dBA would be 4 times 12 plus 6. That's 48 plus 6. That's 54 degrees, which means the other one would be 180 minus that, 126 degrees. Let me know if you have any questions. Thank you.